Welcome to a course on complex analysis. When you are given only two options or three options and asking you to choose one, that is quite easy, right? But when you are given an infinite number of possibilities and asking you to choose several things and one among it, how do we choose? It is up to us, right? So likewise, we can choose the domain in the entire plane as we want and see how it behaves. That is what we are going to explore in this lecture. Come, let's do it.
We are going to continue our discussion on the same example, that is w is f of z, like, just a minute, w is f of z, which is z squared. Okay, now we are going to restrict our domain into this one: x positive, y positive, and xy is smaller than 1. Okay, so we have seen that in the previous one, like when we take v2 b2 xy and we fix this as some constant, this gave us something like this. Okay, so which is going to be something of the same shape. So xy has to be less than 1. If xy is less than 1, then this tells v, that is v of xy, that is 2xy, this has to be less than 2, right? So if you have this as your xy plane and this as your uv plane, you will have, actually you are going to have two curves of this sort. We have restricted our domain to be x positive. Okay, so we have restricted our domain to be, like, sorry, I drew it in the wrong side. So actually here is where we'll have these things. Okay, we have restricted x to be positive, so it can be only on this region, x positive, and we are given that y is also, sorry, I drew it wrongly, x positive, so it can be on this region. Next we are given that y is positive, so it can be on this region. So the common region is only the first quadrant. Whenever we have x and y are positive, we have the region in the first quadrant, and it is given that xy has to be smaller than 1. So our entire, the domain is going to be somewhere from here to here. So this is going to be our domain. Okay, so xy smaller than 1. But if xy equals 1, this is what going to be our v, but it is given that xy smaller than 1, so below which the points are also covered. Okay, suppose this xy is positive and is very close to 0, means what is we are going to have? We are going to have our v value to be also somewhat very close to 0. Okay, somewhere here we would have, okay, it is very close to 0. In this case, here we'll have like this kind of a thing. Okay, so to the maximum, xy can be very close to 1. So in this case, our v will be very close to 2. So this is what we'll have. Okay, so this point is going to be 2i, right? So now can you see what is happening with this, right? If we take domain like this, this is the change that is going to happen with this. Now, instead of considering this as the open domain, if you consider this as the closed domain, that is x shall be greater than or equals 0 and y shall be greater than or equals 0, and xy shall be smaller than or equals 1, this u axis is also included. Okay, so this region, okay, this is going to cover a region of this sort, and this region is mapped with the infinite strip, this one, because from 2 to 0 all the points are included, so this is going to map with this infinite strip. Okay, if this is domain, then this region maps to the infinite strip, that is 0 less than or equals v less than or equals 2 under f of z equals z square. This is the image of, like, only the imaginary part. Here we are talking about only the imaginary part. We have not spoken about the real part. Okay, under this mapping, this region in the xy plane is mapped to this infinite strip. This is what we have done. Okay, now again with the same example, that is w is z squared, but now with the help of polar coordinates we are going to do something. Okay, here this is given. Usually we take z to be r multiplied with e to the power iota times of theta. Then w becomes what? R e to the power iota times of theta whole squared, and this becomes r squared e to the power I 2 times of theta. Right? So when you give a polar notation to a complex number, similarly a notation shall also be given for this w. Okay, suppose w is rho times of e to the power iota times of phi, then what? So your rho is r squared and phi is 2 times of theta. Okay, here your r is nothing but absolute of z, and theta ranges from minus pi to pi. Okay, this is what. So now if you consider a points on some circle, like if we choose points on this circle, okay, then they are mapped to r naught squared onto this circle. Actually this is happening, like now we shall restrict our cases. Okay, this is x and this is y. Let this be origin. Okay, let us consider only this part of, okay, this is r naught. So here what is going to happen? That is, we have r to be non-negative and theta varies from 0 to pi by 2. Okay, so this is mapped to what? R squared. Okay, this is the region that we consider. Okay, under the mapping w is z squared, what is going to happen? Rho is r squared. So if this is r naught, so we are going to have r naught squared. Okay, and theta ranges from 0 to pi by 2, therefore, okay, we have taken okay, we shall write r naught itself. So r naught squared, which is also non-negative, which is of course non-negative, and 0 less than or equals phi less than pi. So from here to here it will go. Okay, so this is uv plane and this is xy plane. That is, if you take points on this quarter circle, this is mapped with the points on this semicircle. Okay, and if you take a semicircle here, like if you take a semicircle here, this will map with an entire circle. Okay, having that as the radius, you may very well see like here, if your r is your radius, here you will have r square as the radius, but this will give you a complete circle. Okay, whether this is mapped in a one way or onto way, that we are not very sure, but like it is mapped onto, but one may not happen in all the cases, right? So likewise here in the previous lecture and in this lecture also, what we have done is that we have considered a single example, that is w is equals z squared. Okay, we have considered several domain for this mapping and see what can be the images. Okay, if we consider it in rectangular coordinates, how is it getting mapped? When we consider it in the polar coordinates, how it is getting mapped, and all those things we have seen. These are some possibilities. Okay, likewise we may see several possibilities and see what is happening with this. Okay, I request all the viewers to pay attention and try to understand what is happening with the functions of complex variables. Once you understand the functions of complex variables in a clear way, your entire complex analysis is easy to you people. Hope you will experience the happy learning process. Thank you.